Logarithms are not that hard to master, but they do take some time to get used to. So it's one of those things, the more that you practice them, the easier that they'll get. And so repetition is going to be the key on this one. So let's get a little bit of a definition maybe. Um, let's say this, a logarithm is another way, is sort of another way to write an exponent. So what do I mean by that? Well, let's look at an example. Okay, let's say I have this log. That's how we abbreviate it. Base 2 to the 4 equals 2. So you have your log symbol, then that little number below is called the base, log base 2 of 4 equals 2. Well, what you do is, that just means your base, so you have this number to the power of this number equals this number. Or 2 to the power of 2 equals, I'll come back and put the equal sign, 4. So whatever your base is goes in red, is the whatever your log base is the base of the exponent, which is 2. Whatever it equals is 2, and so in this case, you know that like it's a way to sort of, it's asking a question, I guess. You could say like this. You say, if you looked at just the left-hand side of my equation, you say 2 to what power equals 4? And that's sort of the rhythm you want to develop. 2 to what power equals 4 is how you're going to want to look at these things. So let's take another example. Well, how about if we did log 2 to the x equals 4? Well, what is that? Well, we know that we have the base 2 to the power of 4 equals x. Well, we know that 2 to the power of 4 equals 16. So we know that x equals 16. Let's look at another example. How about log 3 to the 9 equals x? Well, this implies that 3 to what power equals 9? And in this case, we know that x has to be 2, because 2 squared equals 9. So see, just start, and it's just that natural pattern that develops. Like 3 to the power of x equals 9. 2 to the power of 4 equals x. Just the more that you start looking at these, the easier it's going to be to recognize them. So let's take a look at the graph of a logarithm, or the basic graph maybe of a logarithm. Oops, too far. All right, so it'll start like this, and it'll go something like that. You'll notice it passes through the x-axis at 1. Now, if you are an astute observer, you will notice something. This graph right here is actually the inverse of the exponential graph that we just went over. So the exponential graph, we'll put it in red, looks like this. So that's b to the x. Right? And then here is the log of x. So you'll see these are inverses. So if you looked at it, the graph, just by looking at the graph, you could see that taking the logarithm of something is like the inverse of its exponent. Let's just do a few more to practice. You'll get plenty of practice, but again, just notice the pattern that develops. So how about log 16 of x equals 1/2. What does that one look like? Well, this says 16 to the power of 1/2 equals x. Well, remember, if I take anything to the power of 1/2, that's just like the square root of 16, which equals 4. Let's look at another one. How about log base 8 of 2 equals x? Well, this implies that 8 to some power x equals 2. Well, we know that 8 to the 1/3 power equals 2. So x equals 1/3. All right, one last tricky one. How about this one? Log 8 to the x equals 0. Well, this just says 8 to the 0 power equals x. Anything to the 0 power equals 1. So we know in this case that x equals 1. So this might seem like a lot. You might not be fully grasping everything right now, but the more you work through it, you'll see that pattern. You'll see how it begins to develop, and it'll start to become a little bit more second nature for you.